Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Rat Run 39, Together Apart by Marty Sears. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the 9 by 9 grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. Aim of experiment. F and P must both reach different cupcakes by finding a path through the maze. The paths must not visit any cell more than once, share cells, cross themselves or each other, or pass through any thick maze walls. As well as moving orthogonally, which just means horizontally and vertically, they may move diagonally if there is a 2 by 2 space in which to do so, but may never pass diagonally through a round wall spot on the corner of a cell. So you cannot do something like this because that would be going through a round wall spot in a cell. But if there were no round wall spot there, you could have gone diagonally there in certain places where there are no round wall spots. We have fog, where much of the grid is obscured by fog. Entering correct digits may clear fog somewhere in the grid, and no guessing is necessary. We have black courants, where if a black courant sits between two digits, one is double the other. So imagine we have a black courant there. Then say if this was a 2, this would have to be a 1 or a 4 to maintain a 1 to 2 ratio between them. If we have grapes, where if a grape sits between two digits, they have a difference of at least 5. So for example, if this were say a 3 here, this would have to be an 8 or a 9, because there's a grape between them, and the only digits which are 5 or more away from 3 are 8 and 9. So that's an example of how grapes work. We have starfruit, where if a starfruit sits between two digits, they always have the same sum to be, which is to be determined. Okay, right. So any two digits next to a starfruit must have the same sum as any other two digits which are next to a starfruit. That's all that's saying there. We do not have an example of starfruit anywhere in this puzzles right now, so we don't really have anything to give that. We have buttons, where every colored circular button must be visited. Okay. And the digit on a button indicates the number of cells that the rat moves after the button to arrive in a different 3 by 3 box. For example, if the rat moves immediately from the button into a new 3 by 3 button, or into a new 3 by 3 box, the button would contain a 1. Interesting. So every button must be visited. And the digit on the button indicates the number of cells the rat moves after the button to arrive in a different 3 by 3 box. So let's say the rats went something like this. Then so say it was going this direction. Then this would have to be 1, 2, 3, which are the number of cells the rat moves to arrive in a different 3 by 3 box. And this would have to be 2, because this would have to be 1, 2 for these digits to go for that to go to another 3 by 3 box. So that's how buttons work. Finally, we have the test constraint, where a digit on a path may not be consecutive with the digit visited immediately before it. So that's why this can't work. This cannot be the actual path, because this would be a 3 and that would be a 2, and 2 is consecutive with the digit visited immediately before it, which is a 3. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so then these cannot be consecutive on the path. They must be on different paths. Because if they were on the same path, then they would necessarily have to be consecutive, right? Because you'd have to go here, then here, or here, then here. And then one of these digits would be count the number of digits to the edge of the 3x3 box, and so would the other one. But then that's not going to work, because then they would be consecutive and they would be on the path before. So we know these cannot go next to each other. So this must enter and exit this way. This must enter going that way, and then... So either way this goes, whether it enters or exit, this is a 2. So that's a 2. This cannot be 2, because we have a 2 already in the box. So it must be longer than 2. So this cannot... So this must be going in this way. So this is at least 3. So 1, 2, 3 could work. 1, 2, 3, 4, 5 does not work, because 5 can never be 5 or more away from another digit. So this must go, whichever path is, go that way, and this is 3. And 3 is 5 or more away from 8 or 9. We don't know which way this goes, though, here. This must be visited. So this must go along this path here. So she has to go there, and that's a 1. And then you cannot cross, so you must go that way. This cannot go here, so this must continue on to there. Oh, this is not necessarily 1. This could be 1 or 2. But this has to go this way. And in fact, this is 2. Because it has to be going this way. So it has to be going this way, and then going 3 to go there. Right. So this is 2. So this is going this direction. This could go either way. 2. So this must go out that way. And it must exit out. So this is either 1, 2, 3, 4, 5, or it's 1. So this is going that way. So this cupcake must be reached by coming from this direction here. This is going that way through. Okay. If this rat goes this way, the problem is the path would have to go here, but then it can't exit out. So this rat cannot go this way. Can this rat go this way? And the answer is no. Because if the rat goes this way, this path just fizzles out and doesn't go to a cupcake. So this path must be going along here. And this rat has to go that way. It could just be that this rat enters that, and that's done. But we don't know. Anyways, this has to be 1 or 5. And this is 1 or 5 in this box, because either it enters in here, it's 1, then you have 5 there, or it enters this way, going this going 5 and this exiting at 1. That eliminates 1 and 5 in the rest of the column. So we are left with what? 3, 4, 6, 7, 8, 9 in the rest of this column. And these add up to the this cannot be 3 because of 3 in the box there. These must add up to the same sum as this. This is in a 1 to 2 ratio, so it's 1, 2, 4, or 8 as a possibility. There are 4 digits in this column, which it must add up to. So it must be at least 3 and 7 and 4 and 6, which add up to 10. Or it's at most 6 and 9 or 7 and 8, adding up to 15. So this digit is got to be the same as that, because these add up to the same sum as these. So we have 4, 6, 7, 8, 9 here as possibilities. 1, a digit on the path may not be consecutive with a digit visited immediately before it. And if 1 were here, either way, the 1 and the 2 would be consecutive. So this cannot be 1 here. Where's the 1 in box 4? It must be there. That means 5 has to be one of these two, so this cannot be 5. It must be 1 here, which makes this 5. That means this can't be 5, so that's 1. And so it's traveling this path. 1, 2, 1 there. So that eliminates 1 in the rest of this box. So this has to be a 4 here. That eliminates 4 in the rest of this box. 5 has to be one of these two. This can't be 4 because that's consecutive with 5. So this has, then we have to have a 4B here. Okay, remaining digits in, well, where is the 2 in column 2? Can't be here because of 2's in the boxes, so it has to be one of these 2 digits here. Remaining digits in column 2 are 2, 5, 6, 7, 8, 9. But this can't be 5 because of 5 in the box. 2, 5, 6, 7, 8, 9. No 2 here, so it's 5, 6, 7, 8, 9 remaining here. This can't be 5 because this digit must be 5 or more away from another digit. And 5 is not 5 or more away from another digit. So this is going to be a high digit, which has to be 5 or more away from 3 or 4 here. So this has to be 8 or 9. That eliminates 8 and 9 in the rest of the column. Because of this 8-9 pair, that eliminates 8 and 9 in the rest of column 2. So no 8, 9 here, no 8 here. It's 2 and 8. That means this can't be 2 here. This must be 5 and 6 or 5 and 7 here, adding up to 11 or 12. Interesting. This can't be 3 because that would be consecutive with 4 for that rat. 5 is one of these two. 5 and 6 or 5 and 7 are the star fruit. So we cannot have... This has to be 4 then. Because any other digits here would not work. This has to be 3. So we have to have 3 here. That eliminates 3 in the rest of the column. It can't be 3 or 4. 3 and 8 add up to 11. And 3 and 9 add up to 12. So this is 4 and 7 or 4 and 8 here. That eliminates 4 from the rest of this column. This is either 4, 7, and 3, 8, which adds up to 11, or 4, 8, and 3, 9. Either way, we are guaranteed. 8 is guaranteed in one of these 3 cells here. That eliminates 8 in the rest of the column. So this immediately exits that way. That's 2, then it exits, so this must be 1. So we have a 1 here, which is in a 1 to 2 ratio with 2. These cannot be consecutive, so this cannot be on the same path. So then this must go that way. It cannot go this way because that would overlap, so it must go that way. It could be that it comes from this rat there. Okay. This cannot, we have to have a 3 and 4 in box 1 somewhere, and they cannot be consecutive, so this has to be the other 3 or 4 here. We are guaranteed one of these is a 4. One of these is a 4. There's a, yeah. So this goes that way. This goes this way. This can never be 7 or 8 before it exits the box, because this is already part of that path. So it can't overlap with that. So this has to be 4 then, before it exits. So this is 4, which makes that a 4. I think it either has to go 4 this way, and then there, or 4 this way, and then exit. Either way, this has to go from here. So let's change the color. This will mark as green, or red. Has to go that way, that way. We don't know about this. We'll mark this green. Okay. This must be entered and exit this way. So then this is not black, but green. So that must enter that way, go that way, go that way, go that way. So this must be a 2, because it goes 2 before it exits the 3x3 box. We don't know if this is red or if it's green. So we don't know about that one. Remaining digits of box 7 are 6, 7, 8, 9. And this is also 6, 7, 8, 9 here. So this must be 6, 7, 8, 9 here. This is 5 there. So this is 7 or 8 here to add up to that same sum. I'm not sure about this. Could just do something like... this must exit out here somewhere. Okay. If this is 3, 8, this can't be 7 or 8 because that would be consecutive with the 7 or 8 that's here. So it can't be 3, 2, 3, or 4. So this is can't be 1 because of 1 in the box. So we have 5, 6, or 9 here. To not be consecutive with this. This can't be 3 or 5. Can't be 1 or 2. Can't be 4, obviously. So it's like 6 through 9 there. Mm. Remaining digits here can be 3, 5, 6, 7, 8, 9. Digits here can be 3, 6, 7, 8, 9. Can't be 3, though, because 2 and 3 are consecutive. Can't be 6, because 6 and 5 are consecutive. So this is 7, 8, or 9. Interesting. Where is this digit here? This digit obviously can't be the same as this because 5 plus that digit must equal the same as 4 with this digit. Can't be here because of that digit's in this column. So it must be either that or that. Interesting. Um, this must exit out this way. And it has to go here. This can't be 1, 2, 3, or 4. It's 5 through 9 there. So where is 3 in column 4? It must be one of these 3 digits. I wonder why we have these gray cells here. Because I don't think they can go on that path. Anyways. These are 5 away from each other, and they cannot be 1 and 3. So we could have 4 here and this being 9. And this cannot be 2. So this has to be a 4-9 pair here. Okay. So we have to have 4 and 9 here. That eliminates 4 and 9 in the rest of the box and row. So that means the remaining digits in row 7 are 2, 5, 6, 7, 8, with a 2 guaranteed as one of these digits. Three cannot be here. Where's 3 in box 5? It has to be one of these 2 digits there. 4 has to be one of these 3 there. 2 has to be one of those 2 there. Okay. Pink could be 1, 2, 3, 4, 5, 6. Or it could be going this way. Okay, how is it gonna have to enter? I think it's entering this way or this way. It's blocked here because this has to continue on there. So, to enter this and get to the cupcake, if it enters this way, the problem is there's going to have to be a path that enters here, but it can't exit anymore, so that's not going to work. So it must enter here and go 1, 2, 3, 4. So it's going to have to either go 1, 2, so 1, 2, 3, 4, 5, or 1, 2. Okay, so it can't go 5 because we already have a 5 in this row. So if it tried going this way, 1, 2, 3, 4, 5, 6. Is that right? No, 1, 2, 3, 4, 5. That would not work. But it could do something funky like that. And that seems to work. So it would have to do something like this. And that's 1, 2, 3, 4, 5, 6, 7. So this has to be 7, which makes that 8. No 7 or 8 there, it's 5 or 6. 8 eliminates 8 here, so this is 4 and 7. That adds up to 11. That's 3 and 8 then. This must be 5 and 6 to add up to 11. That eliminates 6 there, so it's 7, which means this can't be 7 or 8, it's 6 or 9. That eliminates 6 and 9 in the rest of the column. So we have 7 or 8 here. 7 eliminates 7 in the rest of this box, so it's a 5-8 pair. That eliminates 5 and 8 in the rest of the box and column. No 8 here, it's 7. No 8 here, it's 9, which means this can't be 9. That's 8, which is 5 away from 3. Makes that a 4. That's 3 in the corner. We celebrate because we're close to solving it. No 3 or 8 here. No 3 there. This is 4, 9 as a pair. Remaining digits are 1, 3, 5, and 6. This can't be 5 or 6 because 5 in the row and 6 is consecutive with 7. 7 eliminates 7 in the rest of this box. 5 cannot be consecutive with 4, so this must be 8, which makes that 5. No 7 or 9 here, so it's 6. No 6 or 7 here, so that's 9. Okay, this is in a 1 to 2 ratio. No 1, 2, or 4 is available. That eliminates 1, 2, 2, 4, and 4, 8 as a possibility, so this must be 3 and 6. So we have 3 there, that's 6. That eliminates 3, 6 in the rest of the box. So no 6 here. This is then 5, 8, or 9. Cannot be 8, 5 because of 5 in the row, so that's 8 or 9 as a pair. That eliminates 8, 9 in the rest of the box, so no 9 here. It's 5. We have... This can't be 3 or 6, so it's 1 or 5. No 5 here because of 5 in the column. Remaining digits in row 4 are 4, 5, and 7. Remaining digits of row 8 are 1, 8, and 9. Remaining digits of row 6. Sorry, did I say row 8? Row 5. Row 6 is 2, 3, and 6. Okay, no more 7s here. This adds up to a star fruit value, which is 11. No 2, 9. It could be 3 and 8 or 6 and 5. So those are the possibilities. This must be entered into its likely green. This is entered into its likely pink. So this There are not enough digits here to satisfy anything with 7. Because the paths cannot overlap or cross. So this must be a 4-5 pair, which eliminates 4-5 in the rest of the box. So this can't be 4-5, it's 7. So this must enter that way. This has to enter this way. Could be from either here or here. Oh, this cannot be. 8 and 9 are consecutive. So this cannot go this way because that would be consecutive. So it must be going here. 1, 2, 3, and then 4. This must go through every cell of this grid. So this is going to have to go this way. And this is going to have to go this way. So this cannot be 1, because if this were 1, this would have to be 8 and 9 for that to work. And then they would be consecutive with each other. So this cannot be 1. This is 4 then, and this must be 5. Oh wait, no, this could be 5 here also. That's not necessarily the case. This must exit out this way. This must exit out this way. This can only come from here, then. But this could come from here or here. Ooh, so that's not going to be great. Okay. Right. Five. Oh, that's interesting. 7 eliminates 7 here. Remaining digits of column 4. We have 3, 5, 6, and 9. No 9 here because of 9 in the row. 7 can't be here, so 7's one of these two. This cannot go that way because this is already taken, so it has to go that way. It likely just connects up here. 1, 2, 3, 4, 5, 6, 7. So I'm guessing this is probably red. That would be my guess. But we don't know for certain. And this has to go this way because otherwise this would be just 1 exiting out that way. This cannot be 4 here because that would be consecutive with 3. So this is a 5, that's a 4. So this must connect to here. And red has to go this way. So this is correct. We have a guaranteed 2 here, so this cannot be 2 and 3. That would be consecutive, so this must be 2 and 6. Which means this can't be 6. That's 3 and 8. That eliminates 8 in the rest of the row. 8 can't be here. Again, this cannot be 8, 9 as a pair. So one of these has to be 8 or 9. We have to have a 1 here. If this were 8, that would be consecutive with 7. So this can't be 8. This is 1, 9 as a pair. 1, 9 eliminates 1 and 9 here, so that's an 8. 2 and 6 here. Seems fine. One, 2, 3, 4, 5 before exiting. 1, 2, 3, 4 before exiting. Remaining digits here. 1, no 2 or 3, no 4 or 5, 6, 7 doesn't work because 7's consecutive with 8, 9 doesn't work because 8 sets goes consecutive with 8. These digits, 1, no 2, 3, could be 4, no 5, cannot be 6 because it's consecutive with 7. It could be 9 here. Okay. Um, hmm. One of these is an 8. Hmm. If this is 6, this would have to be 1, which would make that 5, but then that would eliminate all possibilities for this cell. So this cannot be 6. So this becomes a 1-3 pair, which eliminates 1 and 3 in the rest of the box, so no 1 or 3 there. It's 5. 5 eliminates 5 here, so that's 6. That eliminates 6 here, so this becomes a 2-5 pair. 1, 3 as a pair there. 6 eliminates 6 in the rest of this column here. It's 3, 5, 9 as a triplet. 5 cannot be consecutive with 4. So then this must be a 9, which makes this 4. 9 eliminates 9 here, so that's 8 and 9 there. Remaining digits of column 5 and column 6. Column 5 is 6, 7, 8. Column 6 is 1, 2, and 4. No 2 or 4 here, so that must be 1. That eliminates 1 in the rest of the box. No 7 here because of 7 in the row. No 8 here because of 8 in the row. This is 5 or more away from 1, which is 6, 7, or 8. One and 3 are not consecutive with each other. They're not consecutive with 5 or 7, so those are both satisfied. Remaining digits of row 2. We have 1, 3, 6, 7, and 9. Row 9, 1, 3, 4, 6, and 9. This can't be 7 because of 7 in the column. Where is the 7 in this box? It must be here. These are 5 away from each other. 4 eliminates 4 here. Where is 4 in row 9? Has to be one of these two digits, which means this is a 4-9 pair here. That eliminates 4 and 9 in the rest of the rows and box, so this can't be 9. That's 6, which makes this 9. That eliminates 9 here, no 9 there. Oh. This has to go through here. Right. So this is green, that has to go through here. It could be 9. This could be 9 also. Could be 5. Yeah, red's going to have to go through here, so green has to get a cupcake in one of these spots. We don't know which. It's either here or here, probably, for the cupcake. Um, hmm. Remaining digits of... Oh, this... Okay. This digit cannot be 1, 2, 3, 4, 5, or 8. So we have 6, 7, or 9 here. Interesting. So cannot go just straight there. 2, 3, 4, 5, 6, 7, 8, and 9 is possible. Remaining digits of... Let's just do all of them. Row 1 is 2, 4, 5, 6, 7, 9. Row 2 is 1, 2, 3, 4, 5, 6, and 8. And row 3 is 3, 5, 6, 7, 8, 9. Okay. No 4 here. No 8 here. No 7 here because of 4, 8, and 7 in the column. No 7 here or here because of 7's in the column. This can't be 3 or 5. That's consecutive with 4. So this is 6 or 9. No 3, 5, or 8 here because of 3, 5, or 8 in the column. We cannot have 2 in either of these spots because we have to have a 2 in one of those two. Because neither of these can be 2. This is 2, 5 as a pair, 2, 6 as a pair. One of these is a 2. Hmm. Um, hmm. Ah, if this were 5, that would make this 2, which would make that 6, which would make that 2. Now that does work. Um, hmm. Never mind. So can it ever be 6? 1. So 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. I don't think it ever can be 6. 1. Can it be 7? Is another question. 1, 2, 3, 4, 5, 6, 7. Yes. So 9 would have to be something funky like this, which does work. 7 would be something like that, or 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. That also works. Hmm. Um, uh, this is the hard part of this puzzle. It's like looking at all the possibilities. Hmm. Where is 9 in column 9? Cannot be here because of the 1, 9, and the 4, 9 pairs in those boxes. So 9 has to be one of these two digits. That eliminates 9 in the rest of the box. Can we actually ever get 6 here, then, is the question. I think the answer is no. Right? This is too long. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And this is too short. 1, 2, 3, 4, 5. So this has to be 7 here, then. So we have to have 7 there. This can't be 7. There's multiple ways, though, to go through that. 7 eliminates 7 here, so where's a 7 in box 2? It must be here. So it could be 1, 1, 2, 3, 4, 5, 6, 7. Or 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2. You can't go all the way around here. That's a 9. 5 eliminates 5 here. Where is 6 in row 1? It has to be one of these 3. Because these can't be 6 because of the 6-8 pair in the box. These are filled out. So 6 has to be one of these 3, which means the rest of this box cannot contain a 6. So no 6 here, no 6 here. This must be 9. That eliminates 9 from being there. We have 2, 5, 6 as a triplet in... also, yeah, 6 eliminates 6 here. We have 2, 5, 6 as a triplet in column 9. So this cannot be 5. 9 eliminates 9 here. Where is 5 in... No, where is 9 in row 1? It has to be here. So that's 9. Which means the cupcake has to go here. This cannot be 1. So this has to be 6. That eliminates 6 here. That's 2, 4 as a pair. 2, 4 eliminates 2, 4 in the rest of this row. So it's 5, 6 as a pair. These are in a 1 to 2 ratio. And they cannot contain 6, so it cannot be 3 and 6, and we can't have a 5 there. this can't be 1, because if that's 1, this would have to be 2, and that's not possible to be 2. So this becomes a 2-4 pair, which eliminates 2-4 in the rest of the column. So no 4 here. This is 9, which makes that 4. No more 6 here. This has to go through all 6 of these. 1, 2, 3, 4, 5, 6. No crossing. So it cannot do some funky stuff like that. So it must go through every single one of these. Which means this is going to have to go there. That's fine. This must go through all 9 cells here. No 9 here. 7 is consecutive with 6 or 8. So you cannot enter here and exit this way. It must be entered in here and then exit that way. So that means it has to go there. Cannot go to the 1. It must go to the 6. 8 cannot cross itself. So it has to go here. Because if we go there, then we can never go here without crossing ourselves. We have to go here, then here, then here, then here. So that's all done. Yeah, this execution part is the hardest. 3, 4, and 3 are consecutive, so this can't be 3. This is 1. Makes that 3. 3 eliminates 3 here, so that's 1 and 3. 1 eliminates 1 here, so that's 3. 3 eliminates 3 here, so it's 5 and 3 there. 5 eliminates 5 here, so it's 6 and 5. 6 eliminates 6 here, so that's 8 and 6. So no more 8 here. We have 1 and 4, which are in a 1 to 2 ratio. Well, 2, 4 in the 1 to 2 ratio. 2, 4 eliminates 2, 4 in the rest of the row. So that's 1, which is in a 1 to 2 ratio with 2, which makes that not 2. So it's 4 and 2 there. 2 eliminates 2 there, so that's 4. This can't be 3 or 5. That leaves that as 8. 1 eliminates 1 here, so it's 9 and 1. That's 2 and 5 as the... I don't really know why that has a pink thing, a spiral in the background. 9 cannot go to 8. So 9 has to go to 3. We cannot go through both 5 and 6 because those are consecutive with each other. So we cannot go this way. So we can't enter here because then the 5 and 6 would be consecutive. So 3 has to go this way, which means we have to go around this way, I think, right? 1, 2, 3, 4. So then it's 1, 2, 3, 4, 5, 6, 7. And that works. And this cannot be 5 because that's consecutive with 4. So this is 6, which makes this 2 and 6. That makes that 5 and 2. Control nodes. Set destination. I don't know what that means. We do have pinks. Oh. We have pinks in all the 1 through 7, I guess. Why is that 2, though? Anyways, that makes that a 5. I don't get what the blues are. So F is the blues. Oh, so P goes through the pinks in normal fashion. 1, 2, 3, 4, 5, 6, 7. So then blue must go through in order 2, 5, 1, 2, 1, 9, 7, and 4. Interesting. Experiment completed successfully, May 27th, 1975. The calibrated portal worked perfectly. Not that I had any doubt. Never before has success been so inevitable. The 8 blue calibration nodes specified the portal's remote temporal destination, a particular superreceptive teleport, SRT, that once existed briefly by accident. This is where F was always meant to go next. From there she will emerge, a Christmas gift to herself, and relive a familiar friendship. This time from the other perspective. Interesting. So F is the same as P, it seems, but from a different timeline. P remains here, alone, but older and wiser. I take solace in knowing that their time together always had to come to an end, in order that it could begin in the first place. It seems silly to even use a different name for her anymore. She'll always be Finks with an F to me. Over 5 formative months, she became her own teammate, mentor, and best friend. I don't think she'll be too sad it's over, though. She seems to grasp, perhaps even better than I, that things have turned out the way that they always would. After a period of getting to know herself twice, she now seems stronger, more content, and ready for whatever comes next. In the final test, we will find out what that is. So she's going to December 25th, Christmas on 1974, which is, I guess, when she showed up in these experiments. Interesting. I guess that's what that teleporter is, the SRT, huh? Huh. Interesting. It sounds like it's reaching a conclusion for Rat Run. Either way, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.